So the objective of this winter school is to provide some insights and tools for landscape characterization, and from habitat mappings, landscape connectivity mapping, and ecosystem services assessment. So it is quite ambitious, but I think we can just give you a broad overview about the advances and outcomes of one project we are involved in, which is the ALICE project that is supported from the European Union Interreg program. And the idea of this winter school is to give you some tools to do this landscape characterization. And these tools, of course, are not maybe the most appropriate ones, but there are some quite advanced ones that could be of interest for your own work. And we try to provide you some data sets and practicals in order that you will be able to replicate these methods to your own case studies. And we won't be exhaustive in terms of methods, of course, but we will give you some of the advanced methods to do that. So let's go through this introduction, and let just give us you to provide you what we are talking. What about what we are talking about landscapes? Okay, so this is a landscape, which is an agropastoral landscape located in mountains somewhere in Europe. And when you are looking at these landscapes, some of you maybe are observing some kind of land covers. So you can see there are some meadows, there are some forests, some of them are deciduous forests or coniferous forests, and there are processes of encroachment. So this is a landscape as seen as land covers. But also you can consider this landscape as land uses. And sometimes it could be like silvicultural land uses, agropastoral land uses, but also a non-land use, which is the abandonment of this land. But of course, you can consider as well landscape as functions and ecosystem services in terms of habitats. For example, meadows could be habitat for a specific species. It could be also an approach as cultural heritage, because you can see there are some old houses dedicated to agropastoral practices. There are also some trails that are dedicated to recreationals. And your encroachment could be a service to limit the erosion of the soils and also to provide some diversity in terms of habitats. But of course, landscapes are provisioning some services like wood provisionings, agricultural provision as well. And between these different elements of the landscape, there are some connectivity, some functions that are very important to consider in order to do some landscape management. So we can define the landscape as the result and support of natural and anthropogenic interactions, legacies, and sustainability. So today we face some big challenge about how to deal with the landscape management, how to be sure that all our policies today are appropriate to make a sustainable development of these landscapes. And it is very important to consider this in order to define very helpful and strategies and policies for the future generation of humans. So we face the challenge of making a good assessment of the landscape usefulness for people today, but also we will face the challenge of defining sustainable policies into the future. Okay, so the idea behind the ALICE project is also to consider the BGINS. What we call BGINS is the blue and green infrastructure network. It means that it helps to define the functionalities of connectivity between patches of landscape that have some functions for some species, for instance, and they are dispersed all over the landscape within what we call the landscape matrix. And the idea of ALICE is to try to assess if the blue and green infrastructure network can be a landscape management tool to optimize and improve the ecosystem services, but not only the biodiversity connectivity. To do so, we use 4 case studies, our experiments in terms of assessment of this implementation of BGINs. And the 4 case studies are located along the Atlantic area of the European Union. And we have 1 case study in Northern Ireland, 1 in Brittany, and 1 in Spain, in Cantabria, and another 1 in Portugal. The objective of the ALICE project is to define, to go towards a better management of the Atlantic landscape through the development of tools to characterize biodiversity and ecosystem services. So I would say that it starts from remote sensing images, try to go through all the process of production of maps, which could be land cover maps, land use maps, scenarios, ecosystem services assessment maps, to provide advices or strategy to define sustainable policies. This project is clearly in line with 2 main science approaches, 2 main I would say, paradigm of the landscapes. The first one is the land change science paradigm, which is defined on the left side of the slide. And the second one is in line with the socio-ecological systems and their resilience over time. And there are very good framework to define the ALICE project as a whole. So today we will go through this winter school through different tools in order to provide maps that could define ecosystem services, that could define landscape connectivities, that could define also the habitats of these landscapes. There is another seminar tomorrow morning. If for some people could be of interest, some people are already registered for these two events. It's to talk about how we can consider the landscape dynamics in order to better define these sustainable policies. And in brief, I will go through the production of the basic inputs for all this approach about the production of land cover mapping. So basically, I would say that there is a whole community of scientists, I would say any kind of collectivities that are working on satellite images to provide land cover maps through different kind of methods that belong to the remote sensing classification approach. But it is a critical step because there is some remaining classification errors. All maps are not perfect, of course. And if you are used to these approaches, you have always this kind of kappa coefficients that could be a good accuracy assessment indicators that never reach 100%, meaning that there are, for a kappa of 90%, there is always 10% of error remaining in this map. Of course, this error can provide also some over or underestimation of the land use and land cover changes. So it means that we have to face and to integrate to try to minimize this error at the very beginning. This error can be due to the pixel resolution. And of course, when we go through long time series over the last 30 to 40 years, for instance, the differences between the pixel size of these satellite images can provide this kind of error between the different dates. For instance, when you do a classification, you can see there are sometimes some kind of salt on pepper effect due to misclassification or to confusion between land cover classes. And this salt on pepper effect are not maybe appropriate to do some land use and land cover change analysis. So if we want to improve this classification and to minimize this error, we can use also some additional data that could be some shapefile, what we call some features in this project. in order to try to put all the classification results into this feature landscape polygons in order to remove all this salt and pepper effect. These features could be from the LPIS database, European database, from agricultural plots definitions, but also they can be made from topographical variables. For instance, we can consider the classes of altitude, the classes of orientation aspects and slopes and so on to create homogeneous features that have the same properties. For instance, the same area in mountains located between 2000 and 2001 meters high, exposed face to the east side, and with a gentle slope and so on. It means that all these polygons could be like ecotone definitions of the landscapes. Then, if we apply this approach to different time series of land cover maps, we can also detect some kind of false change and true change. For instance, if you can see here in 1995, you can detect some fallow lands and forests, and there is a confusion because of shadows that urban area could be there. But in the most recent date, we can see that there are bare soil only and fallow land, shrublands around this place. So it means that the shadow in 2010 was an error that can have been corrected thanks to this trend analysis over this time series. So this is this kind of false detection error, and also you can have some true detection change in terms of urban area, because there were no urban in the most recent old date, but also in the recent ones, you can see they are some urban here. Then some of you can be also interested to go more into details in the land cover classes. For instance, in this map, we have distinguished what are meadows and what are cropland. But in some cases, for instance, to better assess the connectivity between some habitats, maybe you need to go more into details to characterize different crops like maize, wheat, or other crops, but also to distinguish the different type of meadows, permanent meadows and temporary meadows. And you can use different kind of external data, or you can use satellite time series to go through the whole process to detail this kind of maps. I would say that the more you keep on the left side of this approach, the more generic you will be. The more you will be on the right side, the more need of external data you will be. But what we noticed, thanks to the ALICE project, is that if you want to have a good stakeholder engagement in the whole process of ALICE, of your project, of your landscape management progress, you will need to better specify all these maps, because they will be the maps that the stakeholders are using usually. So this is just an example about all the datasets that have been produced during the ALICE project. So you can see the 4 case studies. So this is the French case study, the Northern Ireland one, the Spanish one, and the Portuguese one. And thanks to this data set, I think now we will be able to jump into the program of the winter school, because this data set will be the basics one that you will use for your practicals.